Since June of 2015, I've written numerous articles for the Piano Technicians Guild journal, and now you can read those on my website. So the four articles that I wrote, starting in June, the first one was tuning accurate equal temperament and ideal F and A octaves using rapid beating intervals. Here's the article here, and there's a procedure written there. There's diagrams that show the octave spread. There's a flow chart for measuring the octaves. And the next one, an advanced method for analyzing non-speaking length tension. This is a scientific discussion of piano string stability. If you are scientifically minded and logical, you need to read this. So there it is right there. And there's a couple of discussions of what happens when you do different things to the piano tuning pin, the piano pin, the tuning pin, and some other tables here explaining that. And it's basically a logical explanation, a logical discussion of what happens when you're turning the tuning pin and what happens when you let go of the hammer. Because when you let go of the hammer, that changes the tension in the non-speaking length. And then the next one is oral stretch. So how to tune the treble and the bass to be more accurate. And this article talks about the stretch interval set. There it is. And it should show a picture of it here somewhere. Oops, that's the wrong one. Maybe it's here. Yeah, there it is. So we're talking about different octave sizes and what they sound like when they're in tune, and what to do when an interval is wide or narrow, and how to tune the different notes using the stretch interval set. And the entire set is shown right here, where you have one check note, and no matter which interval you play with that check note, the beats are always occurring at the top. And then finally, unison drift. So this concept, this phenomenon, was discovered by Professor Gabriel Weinrich, and it's called Weinrich drift because of that. And we show pitches of individual strings, and then when you mute the strings, what the pitch of the two strings is when you mute the right, the pitch of the first two, when you mute the left, the pitch of the second and third, and then what the pitch is of all three. And this is what we would expect. This is what we would expect, but sometimes this is what we get. Tune all three so that they're all at the same pitch, play them together, and the pitch drops. Or the pitch starts sliding around, or the pitch slides around and it's sharp. So this article explains that. It talks about what to do using double string unison, and it also explains why it happens using this concept of what Professor Weinrich calls massy or springy, the massy or the springy bridge. But I just show it as bridge moving with string or bridge moving opposite string. So if you're interested in those articles, all you need to do is, on this page somewhere, you're going to find a form that you can just fill out, and I will send you a link to the web page that has these articles.